Hello, and welcome to Dreamology. Let your mind begin to loosen, let your breathing slow down, and let your body feel a little lighter, as if gravity has gently relaxed its grip. Tonight, we are not just looking up at the stars from far below. We are drifting softly through our home galaxy, the Milky Way. It is a vast spiral of stars, dust, and dark matter, turning slowly in space for more than 13 billion years. Beneath that calm, hazy glow are quiet secrets, wandering stars, invisible forces, and ancient remnants that challenge what we once thought we understood. We'll move gently from the spiral arms to the hidden core, from grand collisions to stars that are older than the galaxy itself. You'll hear about black holes, stellar nurseries, and the unfinished story of a galaxy that is still growing. Some of these ideas may surprise you, or simply give your mind something peaceful to dream about as you drift towards sleep. If these calm explorations help you unwind or give you a soothing way to end your day, you're always welcome to like the video or subscribe, so it's easier to find your way back here next time. It also helps other sleepy listeners discover this space, one resting soul at a time. For now, though, you can let all of that go. Take another soft breath, and let's begin. The Milky Way has already met other galaxies before, and it will do so again. Our galaxy can feel like a solid, permanent home, but in truth it was built from the remains of many smaller systems. Across billions of years, the Milky Way has drawn in little companion galaxies, gently pulling them apart and stretching their stars into long tidal streams that wrap around the disk. One such companion, the Sagittarius dwarf galaxy, is being unraveled right now. Far away in the sky, the Andromeda galaxy is slowly drifting closer. In roughly 4.5 billion years, these two great spirals will merge in a vast, quiet collision. Individual stars will almost never strike one another, but the shapes of both galaxies will be completely transformed, folding into a new, larger form. Even galaxies are not truly permanent. They grow, collide, and begin again. Some stars in the Milky Way are even older than the Milky Way itself. Not every star shining here was born here. In the halo, there are ancient, metal-poor stars moving in long, tilted orbits that seem to have formed before our galaxy fully settled into shape. Astronomers think these stars may have come from tiny primordial galaxies that merged with the Milky Way long ago. Their chemical fingerprints show almost no heavy elements, which suggests they were born shortly after the Big Bang. They travel slowly, high above the galactic plane, like elder spirits from an era before spirals, before order. In their soft light, we glimpse a universe that was younger and wilder, still learning how to become what it is today. Our solar system orbits the center of the Milky Way at more than 828,000 kilometers per hour, over 230 kilometers every second. Even at that staggering speed, it takes around 225 million years to complete a single loop around the galaxy. This immense path is called a galactic year. In terms of Earth time, we've only circled the Milky Way about 20 times since the solar system first formed. When the earliest dinosaurs appeared, our system was passing through a completely different region of the galaxy. The stars we see nearby now have not always been our neighbors, and they will not remain the same forever. Everything is moving, quietly, slowly, and without hurry. Even as you rest here, the Earth is turning, the Moon is circling, and the entire solar system is gliding forward through a galaxy in motion. The galaxy itself is still growing. Although the Milky Way is ancient, it is not finished. Even now, it continues to gather material. Thin gas from the spaces between galaxies, stars from captured dwarf systems, and streams of dark matter that sink into its halo. It grows not like a living creature, but like a deepening well of gravity. Sometimes this growth is gentle, as cool clouds of gas fall inward and settle. At other times it is more disruptive, as satellite galaxies are stretched apart and their stars scattered through the sky. The galaxy you live in tonight is not the same one that hung above the dinosaurs. And the one your distant descendants may know could be larger still, slowly stitched together from the remains of 1,000 smaller worlds. We still don't know exactly how many arms the Milky Way has. It sounds like something we should have a simple answer to. How many spiral arms curl out from the center of our own galaxy? Yet from our position buried inside the disk, it is surprisingly hard to see the full design. Dust clouds block distant regions. Vast numbers of stars blur into one another. For a long time, many astronomers thought there were 4 main spiral arms. Newer observations hint that there might be fewer, or that the arms twist, split, and fade in more complicated ways than we expected. Some sections break into fragments. Others wrap farther around than anticipated. Our galaxy may not be a neat, perfect pinwheel at all, but a layered living swirl of stars shaped by many overlapping forces we still don't completely understand. Most stars drift calmly through this structure, but a rare few are flung outward at astonishing speeds, fast enough to leave the Milky Way behind entirely. These are called hypervelocity stars. Some of them are thought to come from pairs of stars that wandered too close to the supermassive black hole at the galactic center. One star is captured and disappears into the darkness, while the other is thrown outward like a stone from a sling, racing into the night at over 1,000,000 kilometers an hour. These runaway stars travel alone, far from the familiar glow of the galactic plane, like bright comets with no path back home. They are gentle reminders that even in a galaxy held together by gravity, there are rare, quiet moments of release. Stars launched into the deep, intergalactic dark, carrying their own small stories with them as they go. The Milky Way and Andromeda are slowly moving toward one another. High above the horizon, Andromeda appears to the naked eye as a soft, hazy blur, a distant spiral much like our own, more than 2 million light-years away. And yet, over immense stretches of time, it is drifting closer. In roughly 4.5 billion years, the two galaxies will meet. The event will not be violent in the way our minds might picture. Individual stars are separated by such wide spaces that they will almost never collide. Instead, their gravity will gently stretch and reshape both galaxies into long, flowing arcs. Tidal tails of stars will unfurl, black holes in each core may slowly spiral together, and after billions of years the two spirals will relax into a single, larger system. It will be less like a crash and more like a slow, elegant dance, our future home written quietly across the sky. Most stars in the Milky Way glide around the center in the same general direction, sharing a common flow. But a few do something different. Some stars, especially those in the distant halo, move in retrograde orbits, circling opposite to the galaxy's main rotation. These rebels likely began their lives elsewhere, born in small dwarf galaxies that were later absorbed by the Milky Way. Their backward motion is a subtle sign of that foreign origin, as if the galaxy carries old memories in the way its stars move. Stories of long ago mergers and encounters, preserved not in light, but in the slow, patient turning of orbits against the stream. Over billions of years, the Milky Way has likely consumed dozens of tiny companion galaxies. It has not grown in isolation. Faint, loosely bound systems have wandered close, been captured by our galaxy's gravity, and slowly taken apart. Their stars now live in our halo, in the disk, and in delicate stellar streams. By carefully studying how stars move and what they are made of, astronomers have identified several of these ancient mergers. One especially significant event, known as the Gaia-Enceladus merger, appears to have added a great many stars and may have reshaped the Milky Way's early structure. Our galaxy is not a spotless, untouched spiral. It is a composite, sewn together from quiet collisions, built from the remains of many smaller worlds. Every star carries a record of its origins in its chemistry. Each one has a unique pattern of elements imprinted at birth, a kind of stellar fingerprint. By reading these patterns, astronomers can trace a star's story. Some stars are rich in heavier elements like iron and calcium, hinting that they formed in dense, busy regions where many generations of stars had already lived and died. Others are made almost entirely of hydrogen and helium, born when the universe was still young and simple. These contrasts allow scientists to group stars into families, uncover old mergers, and slowly rebuild the hidden history of how the Milky Way came together. In that sense, chemistry becomes a quiet time machine, letting us read a star's past like a line of ancient poetry written in light. Spread across the sky are thin, graceful ribbons of stars that curve and arc almost invisibly. These are stellar streams, the remains of smaller galaxies that ventured too close to the Milky Way and were gently pulled apart. As these lost systems orbit, their stars are stretched out by tidal forces, forming long, delicate trails that mark where they once traveled. Some streams circle the galaxy like faint halos, others plunge inward toward the core. Each one is a trace of a past encounter, evidence that the Milky Way has been built up through many quiet mergers. Like the rings in a tree trunk, these starry threads record the ages and events that shaped our galactic home. The Milky Way itself is slightly bent and twisted. It does not sit in space as a perfectly flat, even disk. Instead, one side of the disk curves gently upward while the other bows downward, forming a subtle wave of stars. This warp went unnoticed for a long time, until radio telescopes mapped the hydrogen gas extending far beyond the bright starlight. The distortion may be caused by the soft tug of satellite galaxies or by uneven clumps of dark matter hidden below the disk. Like ripples in a great spinning sheet, the warp shows that even galaxies are never completely still. Over time, they bend, flex, and change shape in response to quiet, invisible forces. From far away, our galaxy might look as though it is slowly dancing its way through space. With your own eyes, you can see only the tiniest fraction of the Milky Way. Under a truly dark sky, far from city lights, you might count a few thousand stars. To us, that can feel like an endless ocean of light, yet it is only a small droplet of what is really there. The Milky Way holds well over 100 billion stars. Most are hidden, tucked behind thick curtains of dust, or simply too faint and too distant for human vision to reach. The soft band of light that stretches across the sky on moonless nights is just the innermost whisper of the whole. We are surrounded by a colossal river of starlight, and yet almost all of it remains unseen, too vast to truly grasp from within. Inside this great system, stars do not all move at the same pace. Unlike the tidy orbits of planets in a solar system, stars in the Milky Way follow more varied paths. Some race swiftly through the inner regions, others drift more slowly along the outskirts. This difference in speed is part of why spiral arms appear. The arms themselves are not solid structures, but patterns, like slow-moving traffic jams of stars and gas sliding through the disk. As these gentle waves of higher density pass by, they compress clouds of gas and trigger new stars to form, lighting up the arms in curls of pale blue and white. Our own Sun is one of the many stars that move in and out of these patterns over time. The galaxy is less like a precise clock and more like a broad, steady current, and we are quietly drifting within it. All of this motion holds together because of something we cannot see. If we only count the matter we can measure directly, stars, dust, and gas, the outer regions of the Milky Way seem to spin too quickly. By simple physics, those distant stars should be flung into space, scattered like leaves in a strong wind. And yet they stay. The best explanation is dark matter, a mysterious kind of mass that does not shine, reflect, or emit any light, but still exerts gravity. There appears to be so much of it that it outweighs all the visible matter in the galaxy many times over. We do not yet know what dark matter truly is, but without it, the Milky Way could not remain intact. It acts like an unseen framework, a quiet scaffolding that keeps everything gently bound together. At the very center of this structure lies a supermassive black hole. Deep in the core of the Milky Way sits a compact region of intense gravity called Sagittarius A star. It contains more than 4 million times the mass of our Sun, yet is confined within a space smaller than Mercury's orbit. We cannot look directly at the black hole itself, but we have watched the nearby stars whip around it at tremendous speeds, tracing out tight, invisible loops. From time to time, gas and dust spiral inward, heating up and flaring in X-rays just before they cross the event horizon and vanish. For now, Sagittarius A** is relatively quiet, almost sleeping. Long ago, it may have shone like a brilliant quasar, bathing the inner galaxy in light. Today, it serves as a silent conductor at the heart of the Milky Way, guiding the slow, relentless dance of stars around it. The Milky Way's central region has a gentle, peanut-like shape. When astronomers carefully mapped the heart of our galaxy, they found something unexpected. The central bulge is not a smooth, round ball of stars, but a three-dimensional form that swells in the middle and narrows at the ends, a little like a slowly twisting hourglass made of light. This unusual shape likely grew out of the galaxy's central bar, a dense stripe of stars that turns very slowly, bending and puffing upward over billions of years. These inner structures have been sculpted by gravity, by countless orbits layered on top of one another. We live in a spiral galaxy, but its core is anything but simple. It is intricate, textured, and very much alive. The spiral arms themselves are shaped by places where stars are born. They are not just streams of older suns, but are woven from the cradles of new ones. Huge clouds of hydrogen, dust, and molecules drift through the galaxy, and when these clouds move through a spiral arm, they are gently compressed and begin to glow with newborn stars. These regions are stellar nurseries, busy, luminous, and full of motion. Ultraviolet light from the youngest stars illuminates the surrounding gas, painting the arms in soft blues and silvers. Each burst of creation outlines the spiral pattern, tracing its curves with quiet fire. Every star, including our Sun, began life in a cloud like this, long ago. All of this is wrapped in a much larger structure, a vast halo surrounding the Milky Way. Beyond the familiar flat disk lies a diffuse, almost invisible sphere that encompasses the entire galaxy. Within it are ancient stars, globular clusters, and great stores of dark matter. Though the halo is faint, it may contain most of the galaxy's mass. Its stars are spread thinly over enormous distances, following long, slow orbits that rarely pass through the disk. The halo also preserves the leftovers of old galactic mergers, streams and shells of stars torn from smaller systems and left behind like cosmic fossils. It is the galaxy's outer memory, quiet and dim, yet still moving, still influencing what the Milky Way becomes. Inside this halo are more than 150 globular clusters. These are among the oldest structures in the galaxy. Dense, rounded swarms of hundreds of thousands of stars bound tightly together. They orbit the galactic center in the halo like moths circling a far-off flame. Many of these clusters are over 12 billion years old, and some of their stars appear to predate the Milky Way itself. Their low metal content shows that they formed before the universe had time to build many heavy elements. In this way, they act as time capsules, holding clues to how the galaxy formed, what it absorbed, and what conditions were like in the early cosmos. These quiet, golden spheres drift patiently above and below the disk, glowing softly in the dark. Today, the Milky Way is calmer than it once was. Long ago, it was busier, with new stars bursting into life more frequently from dense, collapsing clouds. In more recent ages, that pace has slowed. There is still gas available, but much of it is spread thin, warmed, or held in states that resist collapsing into new stars. The galaxy is not finished making suns, but it has settled into a quieter rhythm. Astronomers think that star formation peaked billions of years in the past and has been gently declining ever since. This doesn't signal an imminent end, it simply means we live in a softer chapter, a mature spiral glowing steadily in its middle age, still creative, but no longer in a rush. Some stars are older than the Milky Way's familiar disk. The broad, flat spiral we picture when we imagine our galaxy formed gradually, over time. Yet there are stars in the Milky Way that were already shining before that disk fully took shape. Many of these elders live in the halo, or the thicker, puffier part of the disk. They were born when the galaxy was still a loose cloud of stars, gas, and dark matter, slowly collapsing inward. By studying the chemistry and motion of these ancient suns, astronomers can look back to an era before clear structure existed, before neat spirals, when the galaxy was only beginning to assemble. These stars are quiet witnesses to the Milky Way's birth and the long, slow sculpting of the place we now call home. On the scale of the galaxy, time moves in enormous circles. As the Sun orbits the Milky Way center, it completes one full revolution roughly every 225 to 250 million Earth years. This immense circuit is called a galactic year, a cycle so large that it makes all our calendars feel tiny. During a single galactic year, continents drift, species appear and vanish, and whole geological ages unfold. We are thought to be about halfway through our current orbit. The last time the solar system passed through this part of its path, the supercontinent Pangaea had only just begun to break apart, and dinosaurs had not yet walked the Earth. A galactic year is like the slow, steady heartbeat of cosmic time. In the whole 4.6 billion year history of the Sun, it has completed fewer than 25 of these grand orbits. That is less than many people expect, given its incredible speed, close to 830,000 kilometers per hour. Yet the galaxy is so large, and the Sun's path so long, that each loop takes hundreds of millions of years to finish. We often picture the stars as ancient and unmoving, but in galactic terms, our solar system is still young, a newcomer in a city of older, more traveled suns. We are already part of the Milky Way's motion, but still early in its winding story. Even the way the galaxy spins carries a quiet mystery. According to simple Newtonian expectations, stars farther from the center should orbit more slowly, just as the outer planets move more leisurely around the Sun. In reality, stars in the outer regions of the Milky Way move almost as fast as those closer in. This flat rotation curve breaks the rules we'd expect from visible matter alone. The most likely explanation is dark matter, an invisible, unknown kind of mass that forms a vast halo around the galaxy. Without this unseen component, the Milky Way would not stay bound together. Its outer stars would drift away. With it, the numbers make sense. The galaxy turns more like a solid wheel, not because we fully understand the mechanism, but because something hidden is quietly holding it in place. Scattered throughout the Milky Way are enormous molecular clouds. These are vast, dark pools of cold gas, the raw material from which new stars are made. Most are built from simple hydrogen molecules with a little dust mixed in, and some stretch for hundreds of light years. Deep inside their cold, dense interiors, gravity slowly gathers the gas into clumps that collapse into newborn stars and planets. A few of these clouds are so large and so cold that they swallow visible light entirely, showing up as black shapes against the starry background. They are the galaxy's wombs, quiet, hidden places where the future begins in silence, wrapped in curtains of shadow and gas. When massive stars reach the end of their lives, they stir this calm like distant storms. They explode as supernovae, brief but powerful outbursts that can outshine entire galaxies for a moment. These events do more than mark an ending. They set new stories in motion. Shock waves from the explosion ripple through the surrounding interstellar medium, squeezing nearby clouds and sparking new rounds of star formation. The blast also spreads heavy elements, iron, gold, and many others, into space, elements that were forged in the star's core. In this way, supernovae act like storms in the galactic ecosystem, mixing and enriching the gas, reshaping their surroundings. They are moments of chaos, bright and violent, yet deeply necessary for the galaxy's ongoing life. Threaded through all of this is dust, quietly hiding and revealing different parts of the Milky Way. Tiny grains of carbon, silicate, and ice drift together in filaments and clouds. In visible light, this dust can blot out entire regions of the sky, erasing stars and glowing nebulae from view. But behind that dark curtain, star formation continues. With infrared eyes, telescopes can see through the dust, uncovering glittering nurseries full of newborn suns. What looks like empty blackness is often a cradle. The dust that hides is also part of the process, absorbing energy, helping gas to cool, and sheltering the most delicate stages of stellar birth. What seems like nothing is often the quiet beginning of something bright. Not every cloud of gas goes on to form stars. Across the galaxy, astronomers have found massive, cold clouds that seem ready to collapse, yet remain dark and still. Some are simply too diffuse. Others may be held up by magnetic fields or internal turbulence. These starless clouds drift through the Milky Way like unspent possibilities, rich in molecular hydrogen but untouched by fusion. One day, they may be nudged into collapse, or they may be torn apart by outside forces and their gas reused elsewhere. In these silent regions, the galaxy feels as though it is holding its breath, waiting for just the right moment to begin something new. All of this material is constantly being recycled. Stars live, shine, and eventually fade. In their final stages, they give much of their substance back to the galaxy. Supernovae scatter heavy elements. Red giants shed their outer layers into space. Planetary nebulae expand and thin into the surrounding medium. This enriched gas cools, condenses, and can later gather into new clouds, new stars, new planets, and, eventually, life. Every atom in your body has likely traveled this path. Born in a star, scattered into space, and then collected again into a new form. The Milky Way is not a still backdrop but a great engine of renewal, breathing in rhythm with its stars, creating, dissolving, and beginning again. Among its oldest storytellers are the metal-poor stars. In astronomy, metals mean all elements heavier than helium. The earliest stars formed when the universe held almost none of these heavier elements, because previous generations of stars had not yet had time to forge and spread them. Today, astronomers search the Milky Way's halo for such metal-poor stars. Faint and ancient, they preserve the chemistry of a very young universe. By studying their composition, scientists can peer back toward the age just after the Big Bang, before galaxies matured and before the Milky Way fully took shape. These stars are like fossils made of light, carrying the memory of the cosmos in their simple spectra. Stars themselves do not always remain where they started. A star's birth cloud may be only a temporary home. Over long stretches of time, interactions with other stars, subtle resonances in their orbits, and the slow pull of spiral arms can all change a star's path. Some are kicked to high speeds and flung across the disk or out into the halo. Others migrate gradually inward or outward, shifting neighborhoods as they circle the galaxy. Even our Sun is not thought to be exactly where it began. When astronomers trace the motions of many stars, they see a Milky Way that is anything but static, a galaxy alive with quiet exchanges and rearrangements, where home for a star is rarely permanent. Within this moving system, there may be a broad galactic habitable zone. Just as Earth orbits the Sun in a Goldilocks region, not too hot, not too cold, our galaxy may have its own band of just right conditions. Closer to the core, radiation and gravitational disturbances can be intense. Farther out, in the sparsely populated metal-poor outskirts, it may be harder to form rocky planets rich in heavy elements. Between these extremes lies a wide zone where things are calmer, star densities are moderate, and ingredients like carbon, oxygen, and iron are more common. Earth sits within this gentle band, one quiet orbit in a vast swirl where life may not be entirely unique. The spiral arms that frame this zone are not rigid structures carved into the disk. They are patterns, slow waves of higher density that move through the galaxy. Gas and dust flowing through these waves are gently compressed, and that compression sparks new star formation. Stars drift into the arms, shine for a time, and then drift away again. The arms themselves move at a different speed than most stars, like a traffic jam rolling along a highway while individual cars move in and out. From far away, the pattern looks solid and permanent. From within, it is a flowing arrangement of motion, held together by gravity and time, never truly still. Beyond the visible light of all these stars, the Milky Way is full of quieter, unseen energy. High-energy particles called cosmic rays, born in supernovae and distant galaxies, stream through space and through your body every second. X-rays and gamma rays shimmer from collapsing stars and black holes. Radio waves drift from cool hydrogen clouds, pulsars, and other subtle sources. These invisible signals reveal sides of the galaxy that our eyes cannot see. Its history of explosions, its magnetic fields, and the fading embers of ancient fires. When you look up at the night sky, you only see a thin slice of what is truly there. Beneath the familiar stars, the galaxy hums softly in many colors and frequencies, a hidden symphony playing in the dark. Above and below the Milky Way's center, that hidden symphony includes two vast, ghostly shapes. Stretching tens of thousands of light-years out of the galactic plane are the Fermi bubbles, huge lobes of high-energy gamma-ray light discovered only recently. They rise like twin balloons from the galaxy's core, invisible to human eyes but clear in sensitive instruments. Their origin is still uncertain. They may be the lingering imprint of a powerful outburst from the central black hole, or the faded glow of a long, intense era of star formation in the core. Whatever created them, these bubbles drift silently over the disk, reminders that our galaxy has chapters of its past that we can only glimpse in echoes, soft traces of old violence wrapped in radiance, hanging above the stars we know. We live in a small, quiet spur between the Milky Way's grander arms. Our solar system doesn't sit inside one of the main spiral arms at all. Instead, it rests in a modest structure called the Orion Spur, a gentle lane of stars tucked between the larger Sagittarius and Perseus arms. It is not especially dense or dramatic, and that calm may be exactly what allowed us to be here. In this quieter gap between the galaxy's highways, powerful supernovae are less common and intense radiation storms are less frequent. This peaceful corner may have given life on Earth the long, steady time it needed to appear and grow. From far away, the galaxy looks bright and tumultuous, but in this small spur, there is just enough stillness for complexity to unfold. At the center of the Milky Way, the structure is very different. Instead of a simple glowing hub, astronomers see a thick, elongated bar of stars stretching across the core, a kind of luminous bridge revealed in infrared light. This bar rotates slowly, and its gravity helps shape the inner spiral arms. Such bars are common in spiral galaxies. They form when stars in the disk gradually drift inward and collect along a central line. Over long periods, the bar settles into a stable structure, stirring gas, triggering new star formation, and guiding material toward the central black hole. It is more than a shape, it is a quiet engine that sculpts the galaxy's heart from within. Beyond our own galaxy, we are part of a much larger neighborhood called the local group. The Milky Way does not drift alone through space. It belongs to a loose cluster of more than 50 galaxies traveling together. The two giants of this group are the Milky Way and Andromeda, each surrounded by a family of smaller satellite galaxies. Scattered among them are tiny dwarf systems, faint ellipticals, and star-poor galaxies that may be dominated by dark matter. The local group spans over 10 million light-years and is held together not simply by closeness, but by gravity. We are one member of a widely spaced but connected family, linked by invisible threads of shared motion. Within this family, the galaxies are gravitationally bound to one another. Even though they are separated by immense distances, many are slowly moving closer, not drifting apart. Gravity guides them in a slow-motion ballet across millions of years. Some of the smallest galaxies orbit the Milky Way like moons, looping around, falling in, and sometimes stretching into faint streams of stars. Others travel more independently but remain tied to the group, caught in a shared web of motion. Over very long timescales, the local group may tighten. Galaxies may merge, fade, or be absorbed. It is not a fixed arrangement, but a gentle gathering of island universes, gradually drawn closer by time and the long reach of gravity. The disk of our own galaxy is more layered than it first appears. From a distance it seems like a flat, simple plane, but up close astronomers see a thin disk and a thick disk. The thin disk, where we live, is densely packed with younger stars, open clusters, and gas still forming new suns. Above and below it lies the thick disk, puffier and more diffuse, filled with older stars that contain fewer heavy elements. Their tilted, more elliptical orbits suggest they formed under different conditions, or were stirred by early collisions and mergers. The Milky Way's disk is not uniform, it is textured and stratified, like layers of sediment resting on the floor of a cosmic ocean. Threaded through this layered structure is a vast magnetic field. Though invisible to our eyes, the Milky Way is laced with lines of magnetism that stretch across the disk, rise into the halo, and pass through the interstellar medium. The field is weak by human standards, but across galactic distances it matters. It helps guide the paths of cosmic rays, influences how gas clouds collapse, and shapes how matter flows between regions. It tends to follow the spiral arms, arching above the plane and looping back in ways that are still being patiently mapped. Detecting and studying it requires careful radio observations, but its presence is clear. Our galaxy does not only shine with light, it also breathes with magnetism, a subtle pulse running through its bones. Between the stars, space is far from truly empty. The interstellar medium, a thin mixture of gas, dust, and plasma, winds through the Milky Way like a faint, shifting fog. To human eyes it is almost entirely unseen, but when astronomers view it with radio and infrared telescopes, it reveals an intricate landscape. It forms long filaments, bubble-like cavities, shock fronts, and cold, dense knots where new stars are taking shape. Supernovae carve out great hollows, while stellar winds from young stars sculpt the gas into ripples that span light years. The space between suns is not a void, but a living web of matter and magnetism, the quiet fabric from which galaxies evolve and, eventually, life begins. Flows of invisible particles are moving through you right now. Every second, high-energy cosmic rays, mostly protons and atomic nuclei born in supernovae and distant galaxies, stream across space and pass through your body. They travel close to the speed of light, guided and bent by magnetic fields, bouncing off clouds, and sometimes colliding with atoms in Earth's atmosphere to create showers of secondary particles. Most of the time, we are unaware of them. Yet they carry information from across the galaxy, signs of ancient explosions, traces of powerful accelerators, messages from the intense hearts of stars. Even while you rest, the Milky Way is whispering in particles, in silence, in lightless rays. Despite the tidy drawings in textbooks, our galaxy is not perfectly symmetrical. One side of the disk appears a bit thicker, some spiral arms are brighter or more extended than others, and the warp in the outer disk leans more to one side. Even the number of stars in opposite hemispheres is slightly uneven. These small asymmetries likely come from gravitational encounters, long ago mergers, and the subtle tug of dark matter. They show that galaxies, like living organisms, carry traces of their past in their shapes, scars from collisions, wrinkles from time, and uneven growth that gives each one its own character. High above the galactic plane, in the halo, astronomers have found a star that may be almost as old as the universe itself. It contains almost no heavy elements, a chemical signature of stars born shortly after the Big Bang, before many generations of supernovae had enriched space with metals. This star likely formed more than 13 billion years ago, long before the Milky Way had taken on its present form. Today it burns quietly with a soft red light, small in mass but immense in history. It is more than just another point in the sky. It is a time capsule, a living relic from the universe's earliest dawn. The motions of stars also change as you move from the center outward. In the inner regions of the Milky Way, close to the core, stars orbit much more quickly than those farther away. There, gravity is stronger, concentrated by dense clusters of stars, thick clouds of gas and dust, and the supermassive black hole Sagittarius A star. This pulls stars into tight, rapid orbits that can be completed in only a few million years. Farther out, in the quieter suburbs where the sun resides, stars move more slowly, taking hundreds of millions of years to circle the center. This uneven rotation stretches the spiral arms, twists patterns in the disk, and keeps the galaxy from behaving like a single solid object. The Milky Way moves like a great wheel, but one whose outer rim always lags a little behind its bright, busy core. Within this rotating system, spiral arms form through traveling waves of higher density. These waves move through the disk, gently compressing gas and dust as they pass. The compressed regions spark new star formation, lighting up the arms with fresh, bright stars. Over time, stars drift out of the dense wave while new ones are born behind them, creating a self-maintaining illusion of fixed structure. Like ripples moving across a pond, or a slow traffic jam sliding along a highway, the arms are continually in motion. From a great distance they may look still and permanent. From within, they are a graceful dance of matter and rhythm, guided by gravity and time. Deep inside the spiral arms, new stars begin their lives in the quietest way. Massive clouds of molecular hydrogen, sometimes hundreds of light-years wide, float through space just a few degrees above absolute zero. Within these cold clouds, gravity gradually gathers the gas into denser pockets. As these pockets collapse, the gas warms, spins, and flattens into a disk with a growing protostar at the center. Slowly, the temperature and pressure rise until nuclear fusion ignites, and a new star begins to shine. From the coldest shadows emerge the brightest lights, brought gently into existence by the steady pull of gravity. Many stars begin life not alone, but side by side. They are born in tight clusters, all formed from the same collapsing cloud of gas. Held together by mutual gravity, these groups can drift as families for millions, sometimes even billions of years. Over time, though, gentle but persistent forces start to pull them apart. The tidal tug of the larger galaxy, close passes with other stars, and the slow stirring of their own internal motions. Little by little, the cluster stretches and dissolves. Its stars spread out and blend into the wider stellar background. The night sky you see above you likely contains many of these former cluster members, siblings that have been separated and scattered across the disk, far from one another, yet still sharing a common origin written quietly in their chemistry and in the paths they follow. The night sky you see above you likely contains many of these former cluster members, siblings that have been separated and scattered across the disk, far from one another, yet still sharing a common origin written quietly in their chemistry and in the paths they follow. All of these pieces together, disk and halo, bar and bulge, arms and streams, clouds and clusters, make up the Milky Way as we know it. It is a vast, living system built from uncountable small stories, stars being born and fading away, gas cooling and warming, orbits twisting and crossing over billions of years. On the largest scale we can imagine, this is home, a great spiral turning slowly in the dark, carrying us along as we rest beneath it. And now, our gentle tour of the Milky Way is coming to an end for tonight. We have floated past ancient stars and newborn suns, along rivers of light and shadow, through the long, slow movements that shape our galactic neighborhood. As you lie here now, there is no need to hold on to details. You don't have to remember distances or names or numbers. You can let all of that melt away, like starlight fading behind your eyelids. What can stay with you instead is a feeling, the sense of how wide and calm it all is. A galaxy turning unhurriedly in the dark. Stars following quiet paths that take hundreds of millions of years to complete. And in one small, peaceful corner of that vastness, you are resting. Let your attention come back, just a little, to your breathing. Notice the gentle rise of your chest, and the soft, easy fall with each exhale. Your breath has been here the whole time, steady and patient, like its own small orbit. With every breath out, imagine your body growing heavier and more relaxed. Your feet feel warm and weighted. Your legs are loose and comfortable. Your hips and lower back are fully supported. Your shoulders sink, your arms rest, your hands soften. The muscles of your face smooth and grow very quiet. Nothing is being asked of you now. Thoughts may still wander in from time to time, and that is completely fine. You can simply watch them appear and drift away again, like tiny satellites crossing a night sky. There is no need to follow them, no need to fix or solve anything. If you are still awake, you might picture the Milky Way one last time. See it from far outside, a soft spiral of light turning slowly in a velvet dark. Notice the gentle curve of its arms, the faint glow of its halo, the quiet shimmer of billions of distant suns. Somewhere on a tiny world, in a small bed, you are lying beneath that river of stars. In this moment, you are exactly where you need to be. Held by gravity, wrapped in darkness, supported by everything beneath you. You can release today. You can release tomorrow. You can even release the effort to stay awake. If sleep is already arriving, you can allow yourself to slip fully into it, trusting that your body remembers how to rest deeply and how to wake when it is time. If you find yourself in that soft in-between place, you can simply float there for a while, like a quiet star in the outer arms of the galaxy, glowing gently with no effort at all. The story is complete for tonight, but the Milky Way keeps on turning. Its slow, steady motion will still be there whenever you wish to return, whenever you need a calm space where your thoughts can drift and your eyes can grow heavy. For now, there is nothing more you need to hear and nothing more you need to do. Just breathe and rest, and let the deep, gentle dark of space carry you the rest of the way into sleep.